Now let's talk about problems that are harder and much more difficult in SOLD. So those things that you can come across in SOLD and that you can find much more difficult than those that I've taught you in the previous lessons. So what are those things now? But hopefully you have known what SOLD is. So but before we start, let me underline this the topic. Let me do that again. So difficult encounter in SOLD. Those things that you can find difficult when when they are given to you. So I'm going to teach you in today's lesson. So now you need to stay strong, and we're going to have some exercises in the lesson, during the lesson and after the lesson. You are going to see those exercises that I'm going to be assigning to you as well. So what exactly is SOLD? I've given you what SOLD is. SOLD is basically an expression, something like this, an expression of a square root where the content of the square root is non-perfect number, and the non-perfect square, when it's inside the square root symbol, something like this, it's said to be SOLD. So for example, this square root of 3 is SOLD, because square root of 3, if you have already watched the videos where I talk about this stuff, because this square root of 3 cannot be written as 1, can be written as 2, can be written as 3, because this 3 here is not a perfect square. So you need to keep this stuff in mind. Now I've also taught you how to add to a SOLD. For example, let's say you have 6, let's say root 6 over 2 plus root 3, let's say over 5. So if you want to add these two SOLDs, you want to find the least common multiple of 2 and 5. So the least common multiple of 2 and 5 is going to be 10. So for this 10, you want to divide it by each of the denominators. So you're going to divide it by these 2 first, then afterwards you come back to 5 and divide it by 5. So if you divide this 10 by 2, what it will give you? So 10 divided by 2 is 5. So this quotient over here, which is this 5, you want to use it, multiply it by the second fraction. So 5 times this root 6 and 5 times these 2 right here. So what you should get, root 6 times 5 over 2 times 5 plus this plus sign here. Put it here. Then 10 again, which is the LCM divided by 5. So 10 divided by 5 is 2. So for these 2 now, multiply it by the second fraction, just as you did here. So you should get root 3 times 2 over 5 times 2, these 2 over here. Then at this point, you can, maybe I should make space. Let me make space. So let me put it here. So then you can see that. Now what is root 6 times 5? Root 6 times 5 is the same as 5 root 6. So you are going to take this 5 and move it backward. So you should get 5 root 6. And then what is 2 times 5? 2 times 5 is basically 10. Then plus sign. Then 2 times root 3. By the way, this is 2. So then 2 times root 3. So it simply needs to move this to behind that square root symbol. So to give you 2 root 3 over 5 times 2, it's also 10. So at this point, you can choose among these two common denominators because that is what we're looking for. We want to get common denominators. We want the denominators which were 2 and 5 to be the same. If the denominators are not the same, you cannot add the two fractions. If you want to add two fractions, even though the fraction is a radical fraction, something like this, you want to get the denominators of the two or three fractions that are given to you if you want to add or subtract two fractions. So now that the denominators are the same, then choose one, write it down below the line, then write 5 root 6, then this plus sign, put it between them, then 2 root 3. Now this looks like it's your answer. So is it the answer? So this isn't your answer. You can still factorize 5 root 6 and 2 root 3 by factor out the GCF or the highest common factor of 5 root 6 and 2 root 3, which is so you are going to get. Now what can we factor out here? What can we write which can divide 5 root 6 and 2 root 3? Now first, when you set 5 root 6 as a fraction and you take root 3 to divide it, it's possible. So this 3 will divide this 6 2 times. So leave it behind a 2. So you should get 5. This 5 will remain where it was. 5 root that quotient root 2. Because if you divide this 6 by 3 here, you should get 2. So that is why we have 5 root 2. So we know that root 3 can divide 5 root 6. Let's see if the root 3 will divide 2 root 3. Now set 2 root 3 and root 3 as a fraction. See if root 3 will be able to divide 2 root 3. So you can see that root 3 will cancel the root 3. So the 2 root 3's will disappear. So leave behind these 2 over here. So it should give you 2. Therefore, what you can factor out, it should be root 3. Because root 3 can divide 5 root 3 and can also divide 2 root 3. 5, sorry, I made a mistake. 5 root 6 over here. So maybe I should clear off all this stuff that's over here. So what we should write out is root 3 because root 3 is a factor of these two expressions. So write it out. Then if you recall, when we divide 5 root 6 by root 3, we got 5 root 2. So you need to put it here. And whatever the sign is, put it here as well. Then I want to navigate slightly. So now these 2 root 3, well, when we divided it by root 3, what did we get? This root 3 at the top and the root 3 below cancelled each other, so we were left with 2. So that's it. So you need to put this quotient, which is to put it here, and you can get rid of this stuff that are over here. You can get rid of them, but you need to know how I did it now. So it's a point now, so just write over this 10 here for 10. Now this is the answer for this surge that is over here. So this is the answer. It's root 3 bracket 5 root 2 plus 2 over 10. So that is the answer. So I've just given you this as what I'm going to teach you, because this is what I have already taught you before. I'm just giving you to make you remember what I'm going to do in this in today's lesson. But let me just get rid of everything that is in the screen. Do that again. Now you need to pause the video in order to get rid of, in order to write what is on the screen down. Pause the video and make sure you write everything that is on the screen down. So I'm doing with it. So now, what are the difficult problems can you encounter in SOLD? So I have some exercise here so we can discuss it together. So let me do it this way. Let me put it here. So let's write it down. So this is 2, sorry, so it's 2 root 3 over 4 plus 3 root 6 over 5. So let's try this problem now. Two root 3 over 4 plus 3 root 6 over 5. So you want to get the common denominator of 4 and 5, which is what? It's 20. So I'm going to write it here. Now take your 20, which is the LCM of 4 and 5, they divide it by the first denominator of 4. So when you divide 20 by 4, you should get 5. So 20 divided by 4 is 5. This 5, take it and multiply it by the first fraction. So you get 2 root 3 multiplied by the quotient 5 multiplied by 5 over, now you use the 5 at the top, now you want to use it below it as well. Multiply this 4, the denominator, by the same 5. So that is 4 times 5 plus, put it plus sign here. Now this 20, you want to use it again, divide it by 5. 20 divided by 5 is 4. So for this 4, multiply it just as you did it here by 3 root 6 over 5 times 4, because you want to multiply that 5 by the 4. So at this point you want to multiply everything here together. So 2 root 3 times 5 is what? Simply take this 5 and multiply it to these 2. So you get 5 times 2 is 10. So keep your root 3 the way it was. So that is 10 root 3 over 4 times 5. 4 times 5, 20. The plus sign. Then what we did here was something slightly wrong. We should correct it now. So this one should be times 4. We didn't multiply the 3 root 6 by 4, so that is why I'm doing it here. So plus this plus sign, 3. Now what is 3 root 6 times that 4? I said I simply take this 4 and multiply it to your 3 here. So it should give you 3 times 4. So 3 times 4 is 12. That is 12 root 6 over 5 times 4. That is 20. So now let's split it into two parts. So at this point that we have got common denominators, we want to choose one, but I'm going to get rid of this 12 because we no longer need them. Then let's write 20, one of the denominators, maybe it's 2, maybe let me do it again. So we write 20 over 10 root 3 plus sign, that plus sign, plus 12 root 6. So now, is it our answer? No, we can still factorize the 10 root 3 plus 12 root 6. How can we factorize it? Let's write it here now and let's talk about it. 10 root 3 plus 12 root 6. So to factorize this, you want to look for the highest common factor of 10 and of 12. The highest common factor of 10 and 12 is basically 2. But what about root 3 and root 6? Root 3, we know that 3 can divide itself and 3 can divide 6. But so we know that 3 can divide itself, yes, and 3 can divide 6. But this 6 cannot divide 3. That's what you need to keep in mind. Because if you set 3 over 6 as a fraction, you will get 1 over 2. And 1 over 2, it tells you that the fraction is not reduced to a whole number. But if you set 6 over 3 as a fraction, you should get 2 as your answer. This tells you that you can reduce something like a 6 over 3 to a whole number. And so it tells you that we can divide this 3 by itself, as also we can divide 6 by 3, but we cannot divide 3 by 6. Now what you are going to write out of root 3 and root 6 is going to be the lowest one, which is the 3, because 3 can divide itself, and 3 can divide 6. So you should simply write root 3. Now let me put this over here slightly, and then now if we divide these two expressions, 10 root 3 and 12 root 6 by 2 root 3, do you think that we can do that? Yes, let's try it. 10 root 3 divided by 2 root 3. This root 3 and root 3 will disappear. So we're going to be left with 10 over 2. And 10 over 2 is simply 5. So 10 over 2 is simply 5. So now also, if we set 12 root 6, let me draw the roots again. 12 6 over this 2 root 3, which is the factor to root 3. So we should get, now this root 3 will reduce root 6 to root 2. And this 2 will divide 12 to 6. So what we should have is 6 root 2. So it tells you that these 2 root 3 can divide these two expressions. It can divide 10 root 3 and it can also divide 12 root 6. So this 2 root 3 is going to be the factor of these expressions, the 10 root 3 and 12 root 6 that are at the top of the fraction. So we can therefore get rid of this stuff. But you need to keep in mind what we got here, because I'm not going to do it again. 6 root 3 and 5. So you need to keep in mind that we got 2 answers here. So let me clear off what is here. So I'm going to leave those 2 answers. So I'm clear off of this off as well. Now let's continue. Now let's write 2 root 3 outside as being the factor. 2 root 3 brackets. Now when you take 10 root 3 and you divide it by 2 root 3, this root 3 over here and this root 3 will disappear, and 2 will divide 10 to 5. So that is why you see 5 here. So put the 5 here and your plus sign between them. Then when you take 12 root 6, just as we did it before, and you divide it by 2 root 3. Now this root 3 will divide root 6, because 6 divided by 3 is 2. So you should have root 2 inside, 2 inside the square root symbol. Then this 12 will also be divided by 2 and will give you 6. 12 divided by 2 is 6. So this is what you also write here. Put it here. So you should have 6 root 2. Close the bracket behind. Then we can get rid of this stuff. So write over 20. So now you want to be careful here, because this 2 here, it multiplies to this square root symbol, and so we can also divide that 20 below it by the 2, by this 2 here. Now cancel these 2, then reduce this 20 to 10, because 20 divided by 2 is 10, but these 2 we cancel itself. So what you now have is root 3 bracket 5 plus 6 root 2. Then write 20 divided by 10, 20 divided by sorry, it's 10. So the final answer is going to be root 3 bracket 5 plus 6 root 2 over 10. So that is the answer. Now let's continue. So you need to keep in mind what I did here of these two and of these 20. You need to understand that I'm going to show you uh, now let me show you what I did here. Now let's say you have 4 bracket s plus 7 over, let's say this is over 10. This fraction here is reducible because you need to look for a number that can divide 4 and that can also divide 10. If there is a number that can divide the two numbers, go ahead and use the number to divide it. So therefore 2 can divide 4 and 2 can also divide 10. So what is 2? How many 2's that are in 4? So we have 2 bracket s plus 7 bracket, and how many 2's that are in 10? So we have 5. So here is what we can do to simplify what is over here. Now let me take you back to where I've been teaching you this stuff. So you can see that this 2 is cancelled and divided this 20 into 10. So the same is true with what I just did over here. That this 4 is not really cancelled but reduced into 2 here. And because we are going to divide this 4 and what is below it by their highest common factor. So in this case, the highest common factor of 4 and 10 is 2. So that is why we use 2, and 2's in 4 is 2 and 2's in 10 is 5. So you can see the 5 here. And so let me give another ones to make these things clearer to you before we go ahead to the other stuff that we've also have in this list. So let's say we have 4. Let me use another number. Let's have 6x y multiplied by k plus, let's say, t bracket over 15 m. Now if you are given something like this to reduce, how can you reduce it? Now you need to think of a number that can divide 6 and it can divide 15. If there is a number that can divide 6 and 15, you use it to divide it. If there is not, you just leave it just as you see it, so it won't change. If there's a number, you reduce it. Now there is a number that can divide 6 and 15, which is what? Which is 3. So how many 3's in 6? It's 2. So write 2sy bracket k plus t. Then how many 3's in 15? 5. 5m. So this is the final answer, because you need to reduce the fraction over here to the lowest term, to this lower expression. So the answer is 2sy bracket k plus t, because this will be reduced by the by the highest common factor of 6 and 15. So that is it. So you can see that it indeed corresponds to what you saw here of this 2 and this 20 here. But something is different if you see something like this. I'm going to show you something that you can find different in the stuff that we'll be talking about. Let me give you something that is different. So now what if you see 2 minus bracket s plus k is over 20? how can we reduce this one? Now technically you cannot divide this 2 by 20 because this 2 is not multiplied to this bracket, but 1 it multiplies to this bracket. There is a 1 that is multiplied to this bracket, which is the invisible one of this negative sign that is there. So you can simply write it clearly so that you can see it is 2 minus 1 bracket s plus k, the close the bracket, over 20. So you can see that even though if you want to reduce this one, you are going to use to divide this 20, not these two here, because these two has nothing to do with this bracket. But this negative one, this invisible one, it multiplies to the bracket. So you don't need to, so you cannot divide these two by, you cannot divide this 2 or this 10 or this 20, sorry, you cannot divide them, but you can simply divide this 1 and this 20 if you want to. But you can see that if you divide any number by 1, it will remain as the number. The value of the number will not change, will not decrease or increase. So this form, this form, you can write it as, because multiply this negative sign by whatever is inside the bracket. Negative times x, it's negative x, and negative times positive k, it's negative k over 20. Now this is all you can do here. This is what you can do here. You cannot divide this 20 by this 2 because this 2 is not really connected to the bracket. Just as you can see that what is outside the bracket is 1, even though the 1 is invisible there. There is a 1 here. So the answer for everything here, it should be 2 minus s minus k. That is what you can do. So there is an exception here, so you need to keep that in mind. Sorry. So now let me take you back to the stuff above. So here is the answer. So don't forget how I got the answer. So if you want to, you may reverse the video and watch it again. So let's look at another example now. So the second example, it will be, let me separate this, sorry. So it will be 2 root 3 over 4. Sorry, I was writing 8 root 10 over 6 minus 2 root 15 over 4. So here's another example now. Now let's try it. So you want to look for the least common multiple of 4 and 6. The least common multiple is 24. So now take your 24 and divide it by the first denominator, which is 6. 24 divided by 6, you should get 4. Now this 4, multiply it by the first fraction. So what you should get is 8 root 10 times the 4 here times 4 over 6, that's 6 times 4. The 6 times 4, we know it should be 24. Now, let me misspeak because I just want to make it logically connected to each other. So the second, now this 24, which is your LCM, take it and divide it by 4. So 24 divided by 4 is 6. Now this is multiplied by the second fraction, but you need to keep your negative sign. Put it here. So 2 root 15 times the 6 over 4 times 6. So what we have now is, I'm going to move it upward slightly. So now, what is 8 root 10 times 4? It's simply, you need to simply multiply that 4 that you see I highlighted to this 8 over here. So 4 times 8 is 32. So it goes to be 32 root 10 over 6 times 4, or 4 times 6, it's 24, minus 2 root 5 times 6. It should give you 6 times 2, and 6 times 2 is 12. So you should get 12 root 15 over 4 times 6. So 4 times 6, we know it's also 24. Now that you can see that the denominators are the same, both numbers are the same. So you want to choose one, any one, 24, then write whatever is at the top, 32 root 10 minus 12 root 15 together. So 32 root 10 minus 12 root 15. So that's it. So this line is too long. Let me short it. So now at this point, let's see if we can reduce the expression we see at the top. So can we reduce it? Yes, we can, because you can see that 4 goes in 32 8 times, and 4 also goes in 12 3 times. And we know that, but for this 10 and 15, what number do you think that can divide 10 and 15 each 5? So therefore, the factor, what we can write out of 32 root 10 and 12 root 15 that can divide the two expression, it should be 4 root 5. Because 4 can divide 32, that is the highest common factor of 32 and 12. So if you write this 32 root 10 as a fraction and try to divide it by this 4 root 5, see if it will work. 32 root 10, so divided by 4 root 5. Now, how many 4s that are in 32 now? So there are 8 4s. So we know that 10 divided by 5, 82. So you get root 2, 8 root 2. So the quotient of 32 root 10 and 4 root 5, it will be 8 root 2. So therefore, let me clear off everything that is here. But I'm going to save this 8 root 2. So let me save it, put it here. So now going back to the second expression, 12 root 15, they divide it by, he wants to divide it by the factor. Now can you remember the factor? The factor is 4 root 5. So this is the factor now. So now divide what is here by 4 root 5, or you set it as fraction. Maybe I should just clean it and write it closer to it, 4 root 5. So how many 4's in 12? 4's in 12 is 3. So 15 will be divided by 5 into 3 as well. So the answer is 3 root 3. So I'm going to keep this answer as well, just as I kept this over here. So now let me get rid of this stuff and let me keep this somewhere here. So now let's write the factor, which is 4 root 5 outside. So you need to know that this is 5 here. Then when we divided 32 root 10 by 4 root 5, what did we get among these two expressions? Is it this or this? So this is the expression we got when we divided 32 root 10 by 4 root 5. So therefore, this is the expression that we are going to write in this portion of the bracket. So simply write 8 root 2 minus sign. Don't forget there is a minus sign there. Minus sign. Then we're going to be left with 3 root 3. Then close the brackets. Then draw your line. Then over 24. So now take a look at this 4 and this 24. Can we divide them? What do you see? Yes, we can divide this 4 by 4 and divide 24 by 4 to reduce it. So how many 4's in itself? Any number that is divided by itself, it should give you 1. 4 divided by 4, it should give you 1. So for example, if you divide 20 by 20, you should get 1. So any number that is divided by itself, it should give you 1. Also 2m, that is 2 million, divided by 2 million, it should give you 1. So anytime that a number or a term is divided by itself, it should give you 1. For example, apple divided by apple, what it will give you? It will give you apple. So when an apple is divided by another apple, it should give you 1. So it should give you 1. So anything that is divided by itself is always 1. So just keep that in mind. So let me get rid of this stuff here over here. Now 4 divided by 4 is 1. So if you see 1, that one is not significant. So you don't really need to write it down. So simply write root 5 bracket 8 root 2 minus 3 root 3. So I'm going to write it here, root 5 bracket 8 root 2 minus 3 root 3. Now keep in mind that we haven't divided this 24. And how many 4's that are in 24? 6. So put your 6 here. So this is the final answer for for what we did here. So this is the question. So this is the question here. So this is our answer here. So the answer is root 5 bracket 8 root 2 minus 3 root 3. So that's how we add or we subtract edge sorts.